Howdy. Today I'm going to talk about image processing and linear algebra, which is one of the applications of linear algebra in our real world. And it's presented by none other than me, Stephen Subati. Okay, so here's a preview. So I know we have learned a lot about the field of linear algebra in this class, and one of the first things that we learned in this class was matrices and matrix math, like addition, how to subtract two matrices, how to multiply two matrices. And it can seem pretty boring at first and useless at first when you just learn it. I mean, they're just numbers on the whiteboard, and how do you add them and subtract them seems pretty boring. But if you don't look closely, you can miss the real world application of matrices. I mean, it's not like you use matrix subtraction every day when you go to HEB and buy some fruit. So we don't use matrix masks while doing simple like tasks in real life, but they're actually everywhere. I mean, just like often you hear people that are non-engineers always say, "Oh, another day without using y equals mx plus b." I mean, they're going on their days without using y equals mxb is because they're not paying close attention and they're not looking closely to the details. So today I'll tell you one of the major applications of matrices in our life, in our everyday life, including this one, including you're watching my presentation. So, and I have a question on what this is on the screen. Okay, and what is this on the screen? Okay, so the first one was an iPhone, the second one was a MacBook. And what do they have in common? They both have a screen. And yes, they were both also Apple products. That's just because Apple makes the best products. What can I say? Not a fan of, not a fanboy of Apple by any means. So how are images displayed on screens? Like the video of my presentation that you're watching right now is displayed on a screen because I'm going to post this on Canvas and you can watch it on your computer or on your phone. So each screen has set number of pixels. For example, my monitor right now have 1920. It's a 1920 by 1080 monitor. So that is the definition of high definition. And that means there are 1920 pixels in the horizontal direction and 1080 pixels in the vertical direction. Or you can also imagine my monitor as a 1920 by 1080 matrix. So now every screen that you can use to view stuff becomes a matrix. Like my phone is a matrix, my second monitor is a matrix, my iPad is a matrix. So everything that has a screen can be represented by a matrix. And you may ask, okay, what are the values in this matrix, in this 1920 by 1080 matrix? So each values on the screen matrix, on this 1920 by 1080 matrix, are the representations of the color in each pixel. So each pixel can only display one color. And that's how our images on the screen is presented. Just a matrix with bunch of color map values. So like black, white, etc. So there's bunch of values in this big presentation matrix that you're watching. So going deeper on that, and since red, green, and blue can make up almost all the colors that we can see, each pixel have a value for red, green, and blue, as known as RGB value. So each pixel on the screen has a red value, green value, and a blue value. And this pixel on the screen, this pixel right here, this one pixel, tiny pixel that you can see next to the arrow, has an RGB value of 255, 255, 255. There's 255 for red, 255 for green, and 255 for blue. Because it is a white space, and that is the RGB value for white. So all of these pixels here have the RGB value 255, 255, 255. So all these values on this matrix are the same value as this. Okay, so now you know how everything you see on the screen is just values in the matrix. Then we can introduce some matrix math application into the mix. So now you imagine two matrices with A and B, the images, in with same dimension. That means with the same number of rows and columns. So the matrix. So if you want to add matrix A to B, then the matrix obtained by adding the two previous matrices is shown in the equation. So we've learned this at the beginning of the semester. Matrix A plus matrix B equals matrix C, where A11, where C11 is A11 plus B11, and etc. So this is simple matrix addition. So how is this an application in the real world? Filters. So here are two images which can be represented by two matrices, because every image on the screen is just matrix with some sort of color values. So now here you see is an image on the left and another image on the right. And by doing the same matrix addition that we just did, we can get the C matrix or the C image, which is a filter applied to the first image. Boom. And that's exactly how these image filters work in your phone or in your Photoshop or anything that applies filters to images. They're just doing simple matrix math, adding, subtracting, multiplying by different values of matrices. And they're doing the same boring thing we did in class. Adding these two matrices and come up with these other matrices. Okay, now going deeper. So now I'll show you a live demo of a matrix multiplication in the real world. So imagine my webcam, this square box you can see around me, image represented as M. So I am the matrix M. So bunch of pixels in this matrix. Now multiply it by this matrix on the screen, where there are all ones from the bottom left to the top right corner of the matrix and zeros in every other place. So it's kind of like a mirror image of the identity matrix, if you can imagine. So now if you multiply by my webcam by this mirror image of an identity matrix, this is what it's gonna look like. 3, 2, 1. So it's a mirror image of my previous webcam image. So M multiplied by I prime, this is M multiplied by I prime. It's a mirror of whatever my webcam was. Oh, wrong button. Like this, as you can see. So this is M, and then this is M multiplied by I prime. So it's a live demo of a matrix multiplication application in the real world. Live demo during the presentation. And that's it for my presentation. It's just something that I found really interesting, the application of matrices in our technology and everyday life. I never imagined my screens as matrices and doing a bunch of fun things and additions, subtractions, and as you can see, multiplications was my screens. So now I'm going to view every piece of technology in my life a different way. And thank you for the semester worth of knowledge. I think I went a little bit over time, but I guess you can maybe try to speed up the video. 1.25, 1.5 should probably be around 5 minutes. But thank you so much, and bye-bye.